Hello everyone and welcome to the Backend Masterclass. In this lecture, we will learn how to use Github Actions to automatically build and push Docker image to AWS ECR. First, we have to create a repository to store our Docker images. So let's open the AWS console and select the region. I'm in Europe, so I'm going to choose Ireland. ECR, or Amazon's Elastic Container Registry, is a fully managed Docker container registry that makes it easy to store, manage, and deploy Docker container images. You can look for it in the search box at the top of the page. If it's the first time you use ECR, you can click on this Get Started button to create a new repository. Or we can expand the left-hand side menu and choose Repositories. Right now, there are no repositories yet, so let's click this button to create a new one. You can set the visibility of the repository to either private or public. If you choose private, then no one can push or pull image in this repository unless they're given access permission. Next, we have to fill in the name of the repository in this box. I'm going to use Simple Bank. Note that we must follow this naming convention. You can also configure the tag immutability. If enabled, then it will prevent image tags from being overwritten by subsequent image pushes using the same tag. I will leave it as disabled by default. Another setting is Scan on Push. If enabled, Amazon ECR will do a security scan on the image to help identify software vulnerabilities. I will leave it as disabled for now. The last setting is KMS encryption, which allows us to use AWS Key Management Service to encrypt images instead of using the default encryption setting, AES 256. For now, let's just use a default one. So I'm going to click Create Repository, and voila, the Simple Bank repository is successfully created. Here's a URI of this repository, which we can use to push and pull images later. If you're using AWS CLI tool, you can take a look at this page to see the commands to push Docker images to this repository. Basically, you will have to authenticate your Docker client, build your Docker image, tag your image, and finally push it to the repository. However, normally we don't push the image directly from our development machine. Instead, we will use Github Actions to automatically build, tag, and push the image for us whenever new codes are merged to the master branch. So let's open our Simple Bank project in Visual Studio Code. First, I'm going to rename our existing ci.yaml file to test.yaml and change its name to run unit test because that's the main responsibility of this workflow. Let's copy the content of this workflow. Then I'm going to create a new workflow named deploy.yaml. We will use this workflow to build Docker image and later deploy it to production. Now let's paste in the content of the test workflow and change its name to deploy to production. This workflow will only be triggered when there's a push on the master branch, so I'm going to remove the pull request event from this list. Then in the job section, we will declare the first one to build and push Docker image to Amazon ECR. It will run on Ubuntu latest as normal. Next, we have to write the steps to perform this job. For this, I'm going to use some existing Github actions. On github.com, let's open Marketplace. Select Actions type and search for AWS ECR. There are many results, but this Amazon ECR login action is the official one written by AWS. So let's open it. Here in this page, we can see how to use it. I'm going to copy this template and paste it to our deploy workflow file. Now, as you can see, the first step is to log in to Amazon ECR, and the Amazon ECR login action is used for this purpose. But in order for it to work, we have to provide some credentials to access our AWS account. In this section of the documentation, we can see how to do it with another Github action, configure AWS credentials. So let's copy this template and paste it here as the first step of our workflow. Now we need to provide two secrets, AWS Access Key ID and AWS Secret Access Key. Note that we won't write them directly in this file as plain text, but they should be encrypted and stored in the Github Secrets. Then will be loaded later as environment variables when the workflow is run. We will learn how to do that in a moment. Now, beside the secret, we must also provide the AWS region we want to access. As I'm using AWS Ireland or EU West 1, I'm going to copy its name from the URL of this page and paste it to our workflow here. Alright, now let's create some credentials to allow Github to access our AWS account. In the console, I'm going to search for IAM. Here it is. You can read more about it in this documentation page. Basically, IAM stands for Identity and Access Management. It is a web service that helps you securely control access to AWS resources. You can use it to control who is authenticated and authorized to use your AWS resources. There are several kinds of identity you can set up. You can see them in the Identity section of the left-hand side menu. The first one is User, which represents one single person or application. The second one is User Group, which lets you specify the same set of permissions for multiple users at once. As you can see in this picture, you can create groups for different teams with different permissions, such as admins, developers, and testers. Then another identity type is IAM roles. It is pretty similar to IAM user, but instead of being uniquely associated with one single person or application, a role can be assumable by anyone who needs it. You can learn all about it by reading the documentation. For the purpose of this lecture, we're just gonna use IAM user. So let's go back to the AWS console, select User section on the left menu, and click Add User. First, we have to choose a username for it. Let's say Github CI. Then in the Access Type section, we should choose Programmatic Access, since this is not a human user, but an application instead. This will enable an Access Key ID and Secret Access Key for the AWS API, CLI, SDK, and other development tools. Alright, now let's click Next Permissions. Here we will be able to set some permissions for the user we're gonna create. There are several options. Either add user to group, copy permissions from existing user, or attach existing policies directly. I'm gonna create a new group and add user to it. For the group name, let's call it Deployment. Then in the Filter Policies box, let's search for Elastic Container Registry. In the result list, we can see the full access policy, which allows all administrative access to Amazon ECR resources. The Power User Access provides all access except deletion, or the Read-Only Access that only allows reading data from the ECR repositories. In our case, we want to push or write data to the repo, so we can choose either Full Access or Power User. I'm going to use Full Access and click Create Group. Now you can see the deployment group is created, and the Github CI user will be added to this group. Let's click Next Tags. IAM tags are key value pairs you can add to your user, which can help you better organize, track, or control access for this user. It is optional, so I'm not going to add any tags for now. Let's click Next Review. In this page, we can review all user details before creating it. One thing we haven't talked about is the permission boundary. If you go back to the previous step, where we set up users group and permissions, you can see the Set Permissions boundary section at the bottom. Basically, it is a way for us to control the maximum permissions this user can have. Note that this setting doesn't grant permissions by itself, but it just limits the maximum permissions can be granted to the user. It is also optional, so I'm just gonna create user without a permissions boundary for now. Alright, everything looks good. Let's click Create User. And voila, the GitHub CI user has been successfully created. It is added to the deployment group. And the access key for programmatic access is also available. We can now copy and edit to Github Secrets. So let's open our Simplebank GitHub repository. Open the Settings tab and select Secrets section on the left-hand side menu. GitHub Secrets are environment variables that are encrypted and can be used to provide some sensitive input data to GitHub Actions. There are two types of secrets. First, the environment secret, which will only be available to one specific environment. It is used when you want to have different secret values for different environments, such as testing, staging, or production. And the second type is repository secret, whose values will be available for the whole repository. And this will be the one we're going to use today. So let's click New Repository Secret. For the secret name, let's copy it from our workflow. The first secret is AWS Access Key ID, and we can get its value from the AWS console. Let's copy and paste it in this box. Then click Add Secret. Okay, now let's do the same for the second secret. Its name should be AWS Secrets Access Key. And in the AWS console, let's click Show to see its value. Copy it and go back to GitHub to paste in the value. Then click Add Secret. Alright, now the AWS Access Key and secret are ready. Let's go back to the GitHub workflow. In the second step, the key will be used to log into Amazon ECR, and its output will be used in the third step. Here you can see that the ECR registry variable will take the output registry from the previous step. We also defined another variable for the ECR repository. In our case, it should be Simplebank, as we've created before. So let's paste in the name here. The last variable we defined here is image tag. Basically, we will use a GitHub shard of the commit to tag the image. It's reasonable because each push to master will have different commit hash. So naturally, we would want to tag the image with the new version associated with that commit. Now in the run section, we will run two commands. The first one is docker build, which will build and tag the image locally. And the second one is docker push, to push the output image to ECR. All the variables we declared above are used in these two commands. And I think that will be it. Let's push this new workflow to GitHub to see how it goes. In the terminal, let's run git status to see the change. Run git add dot to stage everything. Git status again to see what's gonna be committed. Then run git commit with a message saying deploy workflow, build and push Docker image to ECR. Finally, run git push origin master to push it to GitHub. Oops, the push is rejected. That's because the master branch is protected, so we cannot push changes to it directly. And a pull request must be created if we want to merge to master. You can add protection rules in the Settings tab, Branches section. Here you can see my master branch protection rule. Basically, I just require the status check to pass before merging, which means that the unit test workflow must be successful. You can also require the number of pull request reviews or approvals if you want. Okay, now because of the protection rule, we have to create a new branch. Let's call it feature CI build image. Then push this branch to GitHub. Now in the Simplebank repo, let's open the pull request tab and click new pull request. The base branch is master, and the compare branch should be feature CI build image. We can see all the changes here. It's looking good. So let's click create pull request. You can change the name and write some description if you like. Then click create pull request one more time. Okay, the PR is successfully created. and the unit test workflow is being run. While waiting for it to finish, let's take a look at the changes we've made. So, the deploy workflow will be triggered on a push to master branch. The first job is to build Docker image. It will configure AWS credentials using the repository secret. Then log in the Amazon ECR, and finally build, tag, and push the image. Okay, now let's go back to the conversation tab. The test is still running, and you can see here the merge pull request button is disabled because it requires the test to pass before merging. Alright, now the unit tests are completed. All checks have passed, so we can click merge pull request, confirm merge, and delete the feature branch. Okay, now if we go to the code, on the master branch, we can see the two running CI workflows. Let's open the deploy workflow. Oops, it failed. The steps to configure AWS credentials and log into Amazon ECR are okay. But there's an error in the build image step. The Docker file is not found. Oh, that's because I forgot one step to check out the code. So let's open the test workflow and copy this step. Then paste it to the deploy workflow as the first step. We're not running this workflow on a Golang image, so let's rename it to just checkout code. Okay, now I think this will fix the issue. Let's commit the change. Deploy workflow, add checkout code step, and push it to GitHub on the feature CI build image branch. We can open this URL on the browser to create a new pull request. Okay, the PR is created. Let's wait for the unit test to finish. Oh, looks like the current branch is out of date with the master branch. That's because we've merged the previous PR to master, but haven't updated it locally yet. So in the terminal, let's check out the master branch, run git pull to fetch and merge the new changes to our local master. Then check out the feature CI build image branch. Now we can run git merge master to merge the master branch into current branch. Everything is up to date, so let's push it to GitHub again. Now we have to wait for the unit test. Let's look at the Files Change tab. We only add one step to check out code, so it's looking good. Alright, now all checks have passed. Let's merge the pull request to master. Here, instead of a normal merge, we can also use squash and merge to combine all commits into one single commit on master branch. It will help keep the commit history on master clean and tidy. Okay, now let's check the list of commits on master branch. On the last commit, we can see the CI workflow are running. Let's open the deploy workflow. It is building the image. All the previous steps were successful. We can expand this step to see the details. Okay, everything is completed now. All steps are successful. The image is built and pushed to Amazon ECR. So let's open AWS Console to check it. Here in the Simplebank repository, we can see one new image with the latest commit hashtag was just pushed, and its size is 26.17 megabytes. Awesome. So that's how we set up Github Actions to build and push image to ECR. Before we finish, I'm going to show you how to check your billing. It is very important to control how much you spend on your AWS services. Just click on your account name on the top right corner and select My Billing Dashboard. Here you can see your spend summary. Scroll down a bit, you can see the top 3 tier services by usage. Right now, we're only using Amazon ECR with 500 MB free storage per month. And up to now, we're just using about 1% of it. But why there's also Amazon Simple Storage service here? Well, that's because ECR uses S3 to store the Docker images. And we're given 2,000 free requests of put, copy, post, or list. So if we go beyond these numbers, we will be charged some money. If you open the ECR documentation page and read about its pricing, you can see that the 500 MB free storage per month constraint is only applied to private repository. Besides this, ECR also offers 50 GB always free storage if you use it for your public repository. So pretty cool, isn't it? And with this, I'm gonna wrap up this lecture about building and pushing Docker images to Amazon ECR using Github Actions. I hope you find it useful. Thanks a lot for watching. Happy learning and see you in the next lecture.